Thanks everybody for coming to my talk. I'm Robert Wagner. I work at Octopus as a lead. Today I'm going to take you a little journey through setting up an integration test environment from scratch, every time. So here, who has integration tests? Put up your hands. Come on, good. Leave your hands up if your integration tests more than the one project. Yeah. So you've got multiple projects that full end-to-end integration tests? No? Not too surprised. They're really hard to set up because you've got a lot of dependencies you need to manage and get in there. Particularly if you end up within a microservices, you might have 30, 40 things you need to deploy onto the one machine or the one environment to get a full end-to-end system working. That's hard. It's time-consuming. So we usually just have the one environment called UAT, right? Or staging, right? The thing you do just before you go to production. And there's only one of them, right? Who's got multiple test environments? Yeah? Cool, awesome. Are they automated or are they manual? Manual, hands? No? Okay, cool. Okay, now, so I just want to know a little bit more about you guys. Who knows about CloudFormation and has used it? Oh yeah, good. Good. I'll show you that then. What about Packer? No? Okay, awesome, cool. So good thing I won't be covering things that you already all know, which is great. You know, that's the whole point. So what I'm going to do is I'm going to show how when you create a branch, I'm going to create a branch in a repository, pretend to do some work, and then show you how you can stand up an environment from scratch just for that branch. And optionally also take in other projects which you've used, say, the same branch name and made changes. So say you had two projects that had to work together and a third one, and use Octopus Deploy to automatically deploy the right version into that test environment so that you get an environment that looks like production except for your changes every time, right? Cool. So I'll show you. I didn't go to talk to you about. I heard all about the one about the lifestyle companies. So I decided to last week start my own lifestyle company. So please don't steal my idea, but I'll show it all to you. Right? I've decided to go have a SaaS product. It's to do with maths. It works out the highest common denominator of two numbers. That's the code. It's beautiful. It's going to be the next unicorn, and it's going to make me millions. Right? So anyway, this is the example web service. It's MEC app, and I'm going to be deploying it to Linux, to an Ubuntu box. Let's have a look at who's used Octopus before. Yep. Okay. Cool. I won't go too far into all the features, but this is my environment or my ecosystem. I've got three projects. My next new big unicorn system, and the two things that it relies on. It requires ROT13 encryption and a widget spinner, because apparently everybody needs whatever those things are, right? So what I want to end up with in this integration test environment here is I want to end up with this version from production, plus my branch of the widget spinner I've already made a change on, and my new change from the highest common denominator project. Right? And I'll set up a little test project here just to coordinate everything and make everything hang together. Yeah. Cool. So first thing I want to do, who's used Octopus tenants? Yep. Who's heard of them before? Okay, cool. Who of those who's heard of them before, who understands them? All right. They're not the easiest thing to grasp. So I'm going to give you a quick pitch about what they are. So say you had a white label product, say a hotel booking website. It's just one piece of code, but you need to deploy it per client, say for each hotel. So Accor gets its own deployment, Hilton gets its own deployment. They might be on different versions. It's not a SaaS product, it's more per client. Hospitals as well, you know, each hospital may be on a different release cycle, and some may want the latest, some may just want to freeze for a while if they've got a big thing on and that sort of thing. So multi-tenancy, you set up a tenant on your project, one per client, essentially, or end user. So you set up a Hilton and a Accor and so forth. Right? and deploy your product to that. Now, I'm going to abuse this feature and set up a tenant per branch of work. You could also apply the same thing and set up a tenant per developer. So a developer machine becomes a tenant with its own tentacles and own deployment target, and use Octopus Deploy to deploy your 30 microservices that they aren't working on, but need to do end-to-end development testing, right? So you can't, instead of cloning the 30 repos, making sure they're up to date, building them, executing them, just use something like Octopus Deploy to put those services onto that person's machine in dev mode, obviously, not for production. But and then whenever a new release happens, you can automatically deploy that. Say the other team's working on an update and releases that to production, you can then use Octopus Deploy to automatically deploy that to all the other developers, nightly or on demand or immediately, right? So they're always working against the latest other code. Otherwise, they might be 3 weeks out of date because they just haven't pulled from Git and built in 3 weeks, right, of the other project they're not directly working on. Anyway, so tenants are another dimension. So usually you have projects and you move them through your environments. Tenants provides another kind of slice of granularity in your deployment. So you may not have a tenant in development or testing, but in production you may have 100, 300 tenants and use 3 different slots to deploy to. And they can each have their own machines and so forth. Right? So that's tenants. So what we want to do is we want to create a tenant. Anytime in GitHub we create a branch, right? Just to set up. It's a little bit of a contrived scenario, but I want to show how you can use some automation, Azure functions to automate Octopus and link it with your other services, your other dev tools. So GitHub has webhooks and Octopus has webhooks. So you can respond to events, write a little bit of Azure function or a Lambda function to kind of join the two systems together. If the system doesn't do something out of the box, you can just write that yourself, like auto scheduling tasks. We don't have a task scheduler. So if you want to deploy a project every day, we don't have that out of the box, but you write a scheduled Azure function to do that for you. Okay? It's, and since they cost you practically nothing, it's almost a no-brainer. So here's my Azure function. If you haven't used Azure functions before, you can either go through the web UI to edit them, or you can upload via source control. I'm just going to go through the UI and set it up because I'm a dirty, dirty hacker. And I'm using Azure functions because I like writing C#. Yeah. So if you get to this screen and you're confused why you can't find the options, it's because you've used this plus button instead of this plus button to create a new function. And thankfully, the Azure team has actually given us a pre-baked webhook handler for GitHub. So I'm going to create a GitHub webhook called create tenant and hit create. Cool. And to save time, I'm going to upload the code that all the code I did earlier. Hang on. Cool. Okay. Great resolution change windows. So what I've just uploaded is I've got an image that I want to just set on my tenant just for fun. I've uploaded a project.json. So this is a .NET Core thing where it tells it what framework I want to compile with and any NuGet dependencies I want. And in this case, I'm using the Octopus library because I want to talk to the server and tell it to go do something. So this is my script, which I'm going to copy into the thing that is going to get executed when my function gets called. So this kind of function runs whenever the API or the URL is hit with some data. So GitHub is going to post some data to this function, and I get it here as a HTTP request message. Is that big enough for everybody to read? Yep, cool. Shout out if you can't see anything. I'm gonna pull the branch name out of the data, which is the ref, the new branch name, and then I'm going to connect to the Octopus endpoint and create a new tenant and link that tenant to all the projects for now. Obviously, you do whatever makes sense for your company, right? That's why something like this isn't built in. It's easier to script this up and make it just right, exactly what you need to do. Right? So we create the tenant if it doesn't exist, and then set the logo. Right? So I'm going to save that, and then I'm going to set up my webhook. So I get the function URL, come over into GitHub. So all the code I'm going to show you is in this repo, Droid integration test demo. So you can go have a look, play around with it, steal it. It's MIT license, so go for it. Yeah, so I'm going to go into settings. I am going, and then webhooks. Add a webhook. Oh no. Please be no second factor. Yes, good. Yeah, it's remembered my second factor. Good. It's going to. I want it to post JSON and the secret. Microsoft has given us this. It's really simple. Make this so easy. And I want to only send individual events on branch or tag created, and not that one. Right. So GitHub's going to invoke my function anytime it's happened. My function is going to talk to Octopus, create myself a tenant. Right. So I'm going to go make my wonderful code change that I want to test out, which is adding a README. Right. Doesn't really matter. Demo purposes, right? And I'm going to put it in a new branch. And really, I hate this like patch 1, whatever that. So but I understand it. Naming things hard, so I don't want to call David. You know, David. I always want to call her David, right? So I'm going to create this David branch. Propose new file. Excellent. GitHub's done it. And if everything works and the demo god's in my favor, it has now created a tenant over here. So go in here, environments back. There's my David tenant. Excellent. Good. Thanks. Yeah. Cool. The other file I uploaded into my into here is test. So this is some test data. This is what GitHub sends over the wire. So I can take that, come over into this test tab, paste it into there, and hit run. It'll go and do a virtual post to that into my function, and I can see all the output there, and it should have created a test tenant. So there we go, got my test tenant. I'm just going to delete that just for clarity's sake. All right. So that's just a sample of how you can use something like this serverless Lambda functions and Azure functions to just wire your systems together, right? Automate that thing that you're doing every other day, right? Cool. And TeamCity should have now, it's almost there building my thing, so that's good. Just refresh. Never runs as fast as when you want it. Anyway, cool. So next step, let's create our integration test. So I've got my tenant now. I've got my environment all set up. Oh, sorry, I've got the basic setup. Now I want to write the scripts that actually stand up a CloudFormation template, run some tests, and tear it all down again on it. Yeah. So let's have a look at code. So CloudFormation is basically a definition of what you want AWS to do. So in this case, I am saying to AWS, please create me 2 Linux servers and open some firewall ports for me. So I have, where is it? Here we go. So I want a AWS instance, please, with a network interface using an existing subnet I've set up, public IP address, please, and I also want a web server instance, please, T2 micro with this particular base image. So this is kind of, if you're not used to AWS, this is the image to use. Like this is a Ubuntu image, just one I've hard-coded in there. And then, you've got port 22 in for SSH because I wanted to connect to it so I can deploy something to it. And I'm opening up port 7000 to 7010, and that's where my wonderful web service is going to run. Okay. And again, another egress output. So basically, this is a definition. This is kind of a command to tell AWS, please make it so, right? Now, if I spin up 2 machines, they're just going to sit there, right? I have currently no way of, Octopus has no way of knowing that they even exist, right? It could go in and interrogate AWS every now, but wouldn't it be great if we could get it to reach out back to, when the machine starts up, to reach back to Octopus and go, hey, I'm here. And you achieve that by using user data. So user data is a script that runs on Windows, so PowerShell on Windows, Bash on, or whatever on Linux. Just gets executed the first time you launch a VM. All right? So in this case, I get the public host name and the instance ID out of the AWS metadata of the machine, and I get the thumbprint of the SSH connection. Then I post that information to the Octopus API in a format with a register request body. And in that register request body, I tell Octopus, please set up a SSH machine as a SSH endpoint with this particular policy, these roles, in this environment, and these tenants. Okay. In this case, they're hard-coded in there for now. So at runtime, the instance ID and thumbprint is substituted into this bits here. But before I do the actual standing up of the CloudFormation, I replace environment ID and tenant ID using PowerShell. Right? So I've got a deploy CloudFormation PowerShell script, which takes just the things like the tenant ID, the environment, the AMI I want to deploy, and so forth, and mushes those 3 files together. I've separated those 3 files out just for ease of maintenance, and I've written a script to kind of put them all into one file and then send it up to AWS using command line tools. All right. So essentially, I put the right variables into the registered JSON file, then merge it into the user data file, file, and then base64 encode it in the special way that AWS wants user data. Right? It's not, which is not as you'd expect it. You have to put actual /n's in the end for some unknown reason. Okay. Right? Does that make sense? I've got this thing, I'm automating. Octopus is going to run this script, put some variables, substitute some variables into it to tell AWS to spin up a environment that looks in a particular way. All right. So I'm going to do that as the first thing. So I'm going to add a process, add a step, and run a script. So I want to deploy my CloudFormation on an Octopus server. I've put everything, this time I've put all my scripts inside source control and uploaded it using a zip package to Octopus so that I don't have to cut and paste. My steps are basically what scripts to run out of that zip package. Right? So my zip package is called integration test AWS. And the script file name I want to run is CloudFormation PS1. And I want to, run it. Cool. So that'll take care of setting up my CloudFormation, my servers. Right? Next step is to deploy all the current projects to, or the right projects to that environment, those new machines. So I've got another script called deploy projects, this time written in C# or C# script. It connects to Octopus and goes, please tell me what releases you have, what's the latest one in production, do you have any that end in, say, the David extension, the pre-release tag with David in it? If so, choose that one. Otherwise, use the one that's in production for me, right? So that when we actually do the deployment, this one gets deployed, and these two get the one with the David extension in it, right? Or David NuGet, I don't know what, pre-version tag in it. All right. So yeah, we're using the Octopus client DLL and using the API to script it all up. So we deploy the projects, we wait for the projects to complete, just polling it because we want all the projects to complete before we can run our integration test against them. Right? So again, just to make sure I get it right, I think I'm going to add that step, which is step Octopus server. Projects. Cool. Inside a package, and this time it's the integration test package. Script file name is CSX. Octopus will automatically detect that it's a CSX extension and use the rights runner for us, which is awesome. And hit save. All right. Third thing we want to do is run our tests. So, which is another step. Script inside a package. Run tests. And just make sure I get it. The test is basically, I connect to Octopus, get all the machines for that environment that are web servers, and I just try and ping them on like I do a request. If I get a 200 response, the test succeeds. Obviously, you want some more comprehensive tests when you do it for real. Again, integration test package, script file name is run test CSX, and we run it. Cool. All right. Now, that's good. And since these are disposable environments, I want to tear everything down when I'm done. Okay? So I'm going to add a step to tear everything down. So delete CloudFormation, Octopus server, sort of package, AWS, oops, AWS package, script file name is delete CloudFormation. This is the command line tools. They're pretty good. I tried the C# API, wasn't as good. The command line seemed to be probably the most understandable thing when you're getting started. So CloudFormation PS1. And I want this to run every time. So even if my tests fail or my deployment fails, I always want to rip it back down. Right? Otherwise, next time I deploy, I've got stale machines kicking around. And lastly, I want to delete all the existing machines out of Octopus on that environment because I don't care about them anymore. I could hook up AWS to, when the machine gets deleted, I could hook it up to call into Octopus and pull it down, but I'm just going to delete them outright. Right? I know I'm done with them. So delete machines. Oops. Cool. Okay, so that's our last script we want to do. Remove machines. Good. Script file name. .csx. And again, always run. Done. So that's our 5-step test process. Set some things up, run some tests, tear everything back down. I did make that one run always, didn't I? Yes. Good. Cool. So before I actually run this, I just want to protect myself here that I don't actually do this for a production environment using production variables and production credentials, right? That would be bad. So I'm going to change the life cycle and restrict this project to only integration tests. So I can't accidentally slip and hit the wrong button, right? In my environments, I've got guided failures turned on by default for this, which means that if a step fails, it's going to pause there and let me go and investigate, right? So, and it's like a manual intervention step if something fails. Cool. And finally, I want to set up my project to use a version number from a package. So I want because I'm only going to set this up once for all my projects, right? These scripts are reusable for this particular integration test, right? So I want to base it off my run tests package because that's the one most likely to change, right? So my version number of my release is going to match the version number of my integration tests, right? So the reason these integration tests would sit outside often of your main repo, it's because it doesn't apply to just one project. It applies to your whole suite of applications that are related. You know, it might be 5, 6, 7 projects. For example, at Octopus, we've got end-to-end integration tests where we pick up server, the tentacle, databases, and we set up a big environment and then run this integration test across it, which represents 5 or 6 different actual repos underneath. So it's kind of a cross-cutting thing. Yep, hit save, and what was it? I always require Tenant, just so I don't shoot myself in the foot. All right, so I'm going to create a release. You'd probably do this automatically after you build. Just create a release when you do a new package, right? Create a release, everything's fine. 1.5, hit save, and I'm going to deploy it. Now, Usually you wouldn't deploy it right away. You would, after your dependent project, say my highest common project built, it would, say TeamCity would call out and trigger this deployment, right? It would, reach to this integration test project and go, please run, right? And you could split it up. You could say, have two different projects, one which sets up the environment, then let TeamCity run all your tests, using NUnit or Selenium or whatever, and then tell Octopus to tear things down at the end, right? Just split it up however makes sense for you, right? But I'm just doing it as one process just for clarity. Cool. So I'm going to manually deploy this. Done. Or manually kick off the deployment. Cool. So what's happening now? It's deploying the CloudFormation. So let's have a look at how that looks over in EC2. So CloudFormation. It's created a new CloudFormation stack in here. And we should see our EC2 instances spinning up. Come on. There you go. We've got our two T2 micros spinning up. One of the reasons I use Linux is that we don't have all day to wait for Windows boxes to spin up. This takes about 2 minutes. So, yeah. So we can have a look at what's actually deploying. Deploy integration tests. Good. Waiting for the stack to be created. Cool. Any questions so far while we're waiting? No? Yep.
This particular job is running on the Octopus Deploy server itself rather than on a tentacle.
That's right, yeah. I've just decided I needed to run on a tentacle. You could have a blessed tentacle with the particular role that it runs on. But in this case, it's running on the actual box because it's not modifying any state on the machine. It's purely scripts that call out to web services. Cool. So we've got our deploy project. It should have, there you go. It's deploying all our projects. So it's automatically picked up the right builds or the right packages, releases from these for my David branch and the production one of the ROT13 encryptor. Yeah. Cool. Right. So it's run my tests. Right, so the test succeeded, and I can go in here and I can check to, oops, there you go, manually test it, and I should get a result back from that. Come on, cool. Oh no, sorry, they've been ripped down already, so yeah, cool. Anyway, so Demogods didn't like me. This was meant to fail, right? Because somebody forgot to install the .NET framework. But I did not change the AMI ID in my configuration. So in my variables for the integration test environment, I've got an AMI ID and all my API keys that I need to tell it which one to upgrade. So if I ever create a new AMI, I just swap the new one into here, right? Cool. And so say there was a problem with your AMI. You had a dependency that you no longer needed. How could you get that on there? So one option would be to use your user data to install that at launch time. But that adds to your launch time. So what you want to do is you want to get that base image, put all your dependencies on top, say Visual Studio for build agents, .NET runtime, .NET Core, whatever you want, right? Install services and configure it, snapshot it, and then persist it back into AWS as an AMI. And AMI is an image ID, and use that for every new launch. So you create a template and you launch it. Right? I'm pretty sure we're all familiar with that pattern. The way we used to do it, and I'm sure everybody has, is you spin up a new instance in AWS or on your local machine. You log in, configure everything manually, run some scripts, and then hit snapshot. Right? Which is great. Except when it comes to security updates. So who updates their machines every week with security updates, their servers? Yeah, okay, cool. So up until we did this automation, our build agents were never updated. They had Windows updates turned off and nobody was looking after them. They ran for months, out of date, on the internet and open. Right? So we started using Packer instead. So Packer is a tool that lets you automate this. You write a definition file and some scripts to install the right things. And it's got plugins for something like for AWS and the other cloud platforms, which take care of all the routine of standing up an instance, running the scripts and tearing it back down, testing and all that stuff, right? It's kind of a framework to do that for you. Cool. So, where is it? So that AMI that I actually ran it with was a base Ubuntu image built just the other day with the latest updates, because AWS or whoever maintains the Ubuntu images always puts the newest security patches on as soon as they can and creates a new base image. Right? I want to use that base image, just chuck my other stuff on top, and every day or every Monday rebuild all my base images with the latest security patches already done for me, plus all my dependencies, right? And then capture that as my new thing, new secure AMI that I want to use for the future, okay? So what does Packer look like? So this is a Packer configuration file. JSON, of course. Could be worse, could be YAML. So we've got a couple of variables. This is our AWS access key. You know, I can pass those in from the command line. I tell it what kind of plugin I want to use. I want to use the Amazon one, please, and I provide all the various things for it. Documentation is pretty good on this. I basically grabbed the example template, pasted it in, ran Packer exe, set up my access keys. 20 minutes later, I've got a brand new AMI image, right? I'd never picked up Packer before that. It's quite good. And then it took me a little bit longer to write the scripts the right way, because Linux isn't my forte. So we want to say which region do you want to use to build the image and where do you want to save it. Find me the source AMI, and I want to use the latest Ubuntu Xenil server, 16.4 server, done by whoever that is, the official Ubuntu team, and use the most recent image out of this kind of wildcard that you can find, right? So I don't need to continually update to tell it what base image to use. Then in what instance type? So this is the instance type just to build the image. So if you're doing a Windows, get yourself 4 or 8 cores and with lots of memory, you know, because it's only up for an hour or so to do all the installation, or 3 hours if you're installing Visual Studio. Tell you how we install Visual Studio. You know. And then just a name, you know, integration test demo with the current timestamp. And then you've got provisioners, and this is the scripts that you want it to run. It can do phases, so you can do reboots in between. So if you're installing updates on Windows, or you're installing a component that needs Windows to reboot, you can have a section which everything to do before reboot, put a reboot in there. Packer will wait for it to shut down and start back up, and then run some more scripts on it, right? Cool. And it's the shell scripts are the things we want to run. The actual scripts themselves are pretty simple. They're just bash scripts, right? Or PowerShell scripts if you're using Windows. You can probably run PowerShell on Linux now. I haven't tried, but I don't see one. Right? It's basically just going to start process of these files, right? So install .NET, install Mono with just apt get install, right? Or chocolatey install, whatever you want to use, right? Cool. Then to kick it off, I've got to build PS1 file, Packer, build, pass my 2 variables in, and the configuration file I want to do, right? So I'm going to do that now. There we go. Use a command I prepared earlier. So what it's doing now, it's going to go find the latest image, base image that I just want to use. It's going to launch this instance here, and then it's going to wait for it to boot up and get ready. Let's have a quick look at what that looks like in EC2. Oops. Thanks. There we go. Here we go. Packer. So I've got a Packer builder micro image. It's running. It's starting up. This whole process is going to take about 2 minutes, right? So I'll move on. Yeah. So it's waiting for SSH for it's trying to ping it every couple of seconds to connect to SSH. Excellent. Good. and it's starting to update mono, I think. Yep, something like that. I haven't actually read through it. Cool. Cool. Oh yeah, so we use this extensively for our build images. So we've automated, we have a build that takes a Windows-based image, installs Visual Studio 2015 on it. That takes about an hour and a half, and shuts it down, images it. And then the process picks that image up and puts Visual Studio 2017 on top of that, and then captures it again, just for our different use cases of build agents, right? Sometimes we just want 15, sometimes we want 15 and 17 on the same machine. Right? Cool. Any questions while that's running? No? Cool. All right. So, triggers for deployment. Yep, cool. All right. Let's let that run. Right, so finally, everything's tested, our tests are passed and all that sort of jazz, right? Let's have a look at our environments. Everything should be torn down, clean. I have nothing, right? Cool, but I'm ready to go production, right? So, this special widget spinner thing, let's change track a little bit. And normally I'd have servers already running because I'm just updating an existing app. But say you were doing machines that were transient. The classic example that we use is garbage trucks or trucks rolling into a depot. There's a Tentacle or a SSH machine installed on them, and you want to deploy to them when they roll in, right? There mightn't be any in the depot while you're doing your release, but they will appear randomly ad hoc on your network to deploy to. Another example is like laptops. You know, you've got something you're deploying to desktops, and nobody might be in the office or connected to the network, right? But you want, as soon as that thing comes back online, you want to deploy to it. Yeah? So I'm going to go and deploy my project now to production. So highest common. Take this one. Why not? Let's promote a pre-release version to production, just for fun. No tenant. Production and hit deploy. Damn. Octopus has saved me, saying I can't deploy if there's nothing to deploy to, right? So I'm going to tell Octopus, no, I really do know what I'm doing, and go, allow me to deploy when there's nothing to deploy to, please. Hit OK. Let's redo that. This is the fastest deployment we can do because it's done. All right? I don't know how long that took. Less than a second, right? Cool. So my application is now in production, except it's not really running anyway. Right? So let's have a look at dashboard. There it is. Looks like it's running, right? So now I want to set up a trigger to say that when the machines come online, please deploy. So I go in here, go triggers, create a trigger, and go deploy. So, and I want to deploy when a machine is created and when a machine is when it's found healthy, let's say that, right? And if it's already deployed, in this case, I just want to redeploy. Good. Hit save, right? So I've got a trigger now set up so that when a new machine comes online, I automatically deploy to it. So I'm going to use the same script as before, CloudFormation script. I should zoom that in. Anyway, it basically says CloudFormation, the stack name is production, environment 3, no tenant this time, and use the AMI that I know is good. Right? So you'd obviously could automate this part. So this is probably just in your larger kind of provisioning. So this would also work with auto scale sets and all that sort of stuff. You know, you don't have to, when a new machine comes on, just please deploy to it. So inside EC2, not EC2, AWS, let's have a look at CloudFormation. So that thing I'm deploying, CloudFormation calls out a stack. So there's my integration test stack, integration test production AWS stack. It's a unique name. Gives me a log of everything that's happening. You know, EC2 instances doing up. I can have a look. You know, what's the actual IDs that are being created. You know, all sorts of things. I can actually have a look at the ending template. You know, this is the template that you just used through the API. And again, we should be getting 2 instances pop up here. Yeah, cool. Right, okay. I'm going to switch over to the dashboard and hopefully we see it deploy if I set up everything correctly. That one. Cool. All right, any questions while that happens? Come on. Yes?
Windows box and
Yep.
say 4 servers, and 2 of them you only turn on when there's high load.
Yep.
There might be a few versions behind. Would it play the latest release before it starts iOS?
It has to start and report in. So usually you'd run a health check to ping it to say, I'm here. Like Octopus needs to know somehow that that machine started up. In that case, I would set up possibly iOS's manual start and use the deployment to actually start iOS, or stop the website or something like that. There we go. It's automatically deployed because my machines have come back online. Excellent. Yeah. Cool. Refresh. Cool. So that's it. Thanks for listening. And any more questions? No? Cool. Thank you very much.